Hello. In this short presentation, we will look to answer the question, can you measure the temperature of aluminium with infrared sensors? To illustrate the challenges, we have an experimental setup using one of our long wavelength infrared thermal imaging cameras, an aluminium target block, and a heating plate to put temperature into the block. The challenge to measure the temperature of aluminium is that it is quite reflective. If it hasn't been surface treated, it will have a low emissivity when looking in the infrared wavelengths. This can be demonstrated in the video clip where the infrared energy emitted from my hand is seen as a reflection on the aluminium surface as I pass over it. If I attempted to measure the surface temperature of the aluminium here, it would be influenced by this reflection. I have set a region of interest on the aluminium block surface, and I am plotting the temperature on the chart using our TimConnect thermal imaging software. You can see that as my hand passes over the block, even though it is not in view of the camera, the infrared energy emitted from my hand is seen as a reflection on the aluminium surface. Aluminium is very good at hiding its true temperature, and this is one of the reasons you should be sure to know how hot it is before attempting to handle it. In order to know what the real block temperature is, I've placed an emissivity sticker on the side of the block. The emissivity sticker has a known emissivity of 95%, and by conduction, i.e. being in contact with the surface, allows us to get a true reading of the aluminium block temperature. But what if you aren't allowed to put stickers on the surface? Let's take a look at the block in more detail. We have already seen the emissivity sticker, but we also have three surface features in the form of holes drilled into the surface. We have a shallow hole, a mid-depth hole, and a much deeper hole. Let's see what happens when we look at these now with the thermal imaging camera. The hole size determines the ability of infrared reflections to escape. The deeper the hole, the less reflections escape, and the higher the emissivity will be. At 6 times deeper than it is wide, the temperature reading of this deep hole matches the emissivity sticker. We have, in effect, created a black body source in the aluminium. So, if you're looking to measure low temperature aluminium, and you either have the ability to create a target feature or can adapt an area to measure against, then there is a solution to measuring aluminium with infrared sensors. Temperature is one of the most common parameters to be measured in industry. Temperature can influence all manner of things, including material properties like colour, shape and size. It can affect how well a machine or process works and its quality and efficiency. Therefore, knowing the temperature of a product, whether it is heating or cooling, or if a machine is running hot, can indicate potential problems. Micro-Epsilon sensors and cameras are able to monitor and feedback temperature information from -50 degrees C up to 3000 degrees C. All are non-contact devices, so can be implemented almost anywhere. Contact us by email on info@micro-epsilon.co.uk or via our website at www.micro-epsilon.co.uk for more information. Thank you.